So, have you ever thought a project would be really cool and easy? Well, it doesn't really always work that way. For one of my classes this summer, I had to do a final project that demonstrated what I learned in the class. Students could choose what they wanted to do for their project as long as it wasn't too simple or complicated. After all, we were given 2 weeks to build our projects. I decided I didn't want to be a simpleton and build a remote control car or do some other simple project, but instead build a pinball machine. I love to play pinball, and pinball machines are something that I find very fascinating. So I figured, why not? I could build a small scale pinball machine for this project. It'd be pretty simple. Since I work on real pinball machines every once in a while, I figured that it wouldn't be too difficult. Boy, was I wrong. So watch the next 45 minutes of me stumbling through 2 very long weeks of building a scaled down pinball machine. Okay, so the first thing I kind of did was realistically kind of model it out. I have on my iPad, I just drew a basic model first on exactly what I wanted. Looked at a bunch of pictures online and kind of thought of some stuff from based off of my experience with pinball machines and stuff. And then from there, designed up this CAD model. I at first planned on fully 3D printing like absolutely everything. So like this entire table and everything would have been printed in 2 pieces. It is 600 by 300 millimeters, I think, excluding this small out thing. I quickly realized that that's not really the smartest idea, especially because it takes so much. I think one print, like without all this extra stuff, just the actual like table itself, was about almost 8 to 9 hours to print on my warrants. That's a lot, and it was like almost 500 or 600 grams of filament. So if I made a mistake somewhere, I would have to completely reprint that, and that's expensive and takes a long time. And I really realistically only have just a little over 2 weeks to do this. I moved to building it out of MDF, I think is what this is, and I initially thought I could just use this poster board foam, essentially just to model everything out. And I think I could definitely do that, but I think it would be smarter to just still go ahead and print out most of the stuff, just the individual pieces, and then just screw them into the board. I'll start to model everything out and print it. This is bigger than what I initially planned on. I don't. So as far as hardware goes, I kind of planned on using these 1/2 inch steel balls, but they are very small, like incredibly small. Which for that 300 by 300 or 300 by 600 table would have been fine. So you can kind of see in comparison to the table, those are fairly small. So I'm gonna move up to 3/4 inch steel balls. They are on their way. I don't have them at the moment. And that'll give me obviously a bigger ball. It's a little bit more fun, I guess. But that also gives me more weight for the sensors and like for switches and stuff. I should start by saying that I plan on controlling this with either Arduinos or ESP32s. At the moment, the plan is ESP32, just because it has more interrupt pins, a lot more interrupt pins. As far as the mechanisms go, there's 5 primary mechanisms, maybe. There's a bit more, but the first one that I tried to address was the flipper mechanism, which would in this case go here actually. If you put the flipper in here, oh well, it's not gonna work. This one, the hole's too small. But essentially, the flipper had a lot too much movement back and forth, and with the push and pull mechanism underneath where the solenoid was, it would cause issues. It would drag on the bottom, or it wasn't very solid. There was a lot of slop to it. So I ordered 3 millimeter rod and 3 millimeter bushings. So hopefully that will be tight enough to get rid of slop. Otherwise, I will also space this up from the table a little bit, and then if I absolutely need to, I can kind of bevel this bottom. The biggest challenge beyond that too is just the strength of these solenoids. This one I planned on using for the flippers. It just did not have enough strength at all, and also the throw wasn't long enough. So I ordered newer flippers, or I meant bigger solenoids with a 25 millimeter throw that are almost, I think these are 20 Newton. Yeah, the new ones have like 70 something Newtons, and they're at 12 volts, I think. So I ordered a 12 volt power supply to run them. And then the side slingshots, which are here on the table. And then technically these are slingshots as well. I wanted to initially actually just do the pop bumpers. That mechanism is pretty complicated, and I can't necessarily do that at the moment. Otherwise, I had also gotten a bunch of these little 5 volt 10 millimeter throw solenoids. These are dramatically smaller, and I actually intended to use these for this, but these have like almost no power. There's no strength to these. So I switched to moving this solenoid that I was going to use for the flippers over to here. This mechanism actually works. This is like the final mechanism, and actually has a lot of power, and will be able to work. And then I did attempt at that point, after that, to use the same solenoid here as the ball eject. I don't necessarily plan on having the pullback thing, because for multi-balls I want it to be able to eject manually, not so that way you can play the game and have more balls eject into the thing. I think that's the simplest way to do it, because if you had it just eject another ball that you had to shoot in, you would have to shoot the ball in while you were playing, which you could possibly do, but that's just kind of annoying. You could also do like another mechanism that releases balls into the table, but again, being higher up here, somehow I'd have to get the balls back to that mechanism. So it's better to just have one mechanism that feeds the balls in and out here. That's why I went with this, and then I won't have, at least for now, I won't have the spring shooter. Maybe later when I figure out how to do the vertical ball push, I'll do that. But anyways, moving on to this, I thought that I was running this USB-C power breakout. I thought I had set to 12 volts, and I thought I was running these at 12 volts. When I first initially tested this, unbeknownst to me, it was still at 5 volts. This would actually only push the ball out to maybe like here or so. And this is the smaller ball, not the one that I'm going to be using, so that was obviously a problem. And at that point, I kind of was like, yeah, this isn't going to work at all. I went to go try to find a 24, like anything close to 24 volts as I could. And then turns out I can change this over to 20 volts on this power supply. And then while I doing so, I decided to check with my multimeter whether it was actually giving out 20 volts. And it was actually giving out 5 volts. Turns out it was hardwired to 5 volts. So no matter what I changed it to on the solder pads, it would stay on 5 volts. So I turned it to 20, and this thing just shot it like crazy hard. So how actual pinball machines work, and they have their solenoids use about 50 volts, I think. They're a lot bigger. They use that 50 volts initially, just for the initial travel. I'm not too sure exactly what the time is on that. After that, they cut down to whatever the voltage they're rated at after the full stroke to hold it open if need be. So they typically actually have 3 prongs on them, and there's a second switch on the flipper assembly. Is really where I'm talking about this. There's a second switch that when the flipper is fully out, it hits that switch and changes the circuit to where it's only operating at like 12 volts or whatever, right? So the solution to that, and I could technically run another switch and then another MOSFET unit running the lower voltages, like the 6 volts that these operate on. But that adds another switch and another wire, so that complicates the mechanism. But I also saw that somebody said you could just run PWM on the solenoids at at that higher voltage. So I purchased a 24 volt power supply, and that should be enough, especially with the significantly bigger flipper motors. I definitely think that'll be enough. And then I can just run PWM on those two solenoids at the moment, because none of the other solenoids I can just straight run 24 volts and have it timed to I think I'm going to do about 80 to 100 milliseconds for each of those, and then they won't overheat because they're not being held at that voltage. So it's only for initial spike, unless you're doing it over and over and over again. I want to talk about another large hurdle that is pretty important to the machine itself, and that's going to be lane sensors, or rollover sensors, or really just a sensor that detects when the ball has gone through a certain point on the machine, right? So in normal pinball machines, there is typically a micro switch underneath with a metal rod like this almost that sticks out, typically, just for reference, kind of like sticks out like this, so that when the ball runs over it, it pushes the switch down, right, and clicks it. And then that obviously sends a signal to the machine telling you that the ball went through in that location. I've also seen some brake IR sensors. One of the machines that I've worked on has one of those. So initially I wanted to use basically these leaf sensors. So I bought some nickel strips you can see here inside. Basically these thin nickel strips right here, because you can solder to them, and you use those as a switch. And I basically wanted to recreate the other line switch, and then basically this would come over, the ball would come over and go over this. But two things occurred at first. Two problems occurred. The first is that these nickel strips are not springy. They're very malleable, so you can bend them, but they typically stay after you bend them. So unlike something like this spring steel right here, which is very flexible because it's spring steel, it's a spring, right? This will bend back in place. This does not. So that's a problem, basically, because it would just go over and then stay there. I would like to just be able to straight use this stuff, but you can't solder to this at all. The solder won't stick to this. So that's a problem. My second idea was to basically just put two of them together. This is with like 3M tape, and this is too stiff at this point. It works in the way that I intended, but it is way too stiff. So I can either try to do this without the tape in between, just have them stuck together, maybe glue them together. It would be best to like spot weld them together, but I don't have a spot welding machine. I messed around with this, and no matter kind of the size and shape that I did, these half-inch balls just don't have enough weight or force on them to actually fully push that's the leaf sensor down, the leaf switch down, right? Even when they were just the nickel strips. So kind of left looking for different options. If you think about something like this, the problem with this is it takes too much force to actually activate the switch with a ball like this. So that's not going to happen. The other attempt that I tried to do, it looks pretty rough now, but essentially adding two strips together like this, so that when the ball comes across, it makes contact with both of them and sends a signal. And this works, but also doesn't. The issue is that if I hold the ball and kind of go over it really fast, it'll work. But the minute that you try to if I say drop the ball here and then let it go over it, it won't work at all. And I think that's because what's happening is that it's actually jumping over. It like hits this first one and kind of hops over it. That, or it's just the timing of it running over is just way too fast. So obviously this isn't going to work. And you might think that it would be better to have them not going this way, but the opposite way, so that they're in contact longer. The problem with that is that you don't know, you can't verify that the ball is going to be in the center. It would have to work if it was only in the center. You can't constrict the lanes, the size of the lane to exactly the size of the ball, because otherwise that'll cause problems. But realistically, The ball might ride on the top or on this bottom piece here, right? It's going to ride on the side. It's not going to be in the center all the time. Okay, one of the things that we utilized in class was these infrared sensors. And I figured that I might be able to use this, but pretty quickly realized that for one, these guys are very big. So in order to put these somewhere to where it's going to detect the ball, it's also going to like interrupt a lot of other spaces. And you can't put this in the bottom because you have to have a hole big enough for the sensor. And that hole is also is very big compared to the ball, and it would definitely get stuck or get hung up on that. To compound that issue, these sensors just suck. I mean, they're so light sensitive, it's insane. Like if I have my window open, they just won't work. And there cannot be an object within like almost half an inch on all sides of the LEDs to detect, right? Because otherwise it'll just be constantly on. So they really really suck. There is some other sensors out there that I'm sure would be better, but again, something that's dependent on light in an open and lit area is not too smart. I believe I discovered the best way to do this is actually to kind of have a slot in the table like this. This is sticking out of the table, and then there's a rod going through the center of it. And so when the ball comes over, it pushes it like this out of the sensor, or it pushes it like this out of the sensor, and then this sensor can still sit inside an enclosed box underneath the table. And I don't need any springs or any force to activate this. It just moves out of the way. I might add like a very, 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 very tiny spring just to make sure that it stays centered. Okay, so I have everything finished as far as putting all the pieces onto the table. So, like I said, they're just 3D printed, and then I was able to use, instead of printing out some like advanced or like a schematic or something, a drawing on paper, I just used these cube spacers and just made sure that everything was lined up. The only other thing for the slingshot here, I did use this template just to sketch in some, like, just mark out the holes, because these were more specific. They're a bit harder to do than these top ones, because I kind of just guessed, and I might actually have to change that top peg right there, because I think the angle on the back isn't steep enough to let the ball come down when I get the new balls in, which I'm still waiting on. As far as securing these down, I used some number 4 1/2-inch screws from the top down into the wood. Problem with this is I have to go manually with this screwdriver, because the hole is too small to get like any drill thing down. So that was kind of a pain in the butt. Targets look pretty good. I'm waiting to solder everything up before I glue on the targets. I think in the future, as I sat here and kind of like threw one of the smaller balls around to kind of test and make sure things work, I want to do a ramp here and then a ramp right here in the middle. Like the ball will still be able to get through behind the ramp, but I want this to be a ramp, just because it's like this shot specifically, like just shooting it up through here really doesn't do much, and you can easily get the ball to go over. Okay, as far as the buttons go, I have these ones that I plan on using, which are screwed holes into the sides here. These are too small, and none of the drill bits that I had are the right size. It was either 1/2 inch or 3/4 inch, and this is bigger than 1/2 inch and smaller than 3/4 inch. So I'll have to print out a some sort of like interface casing to set them in there. I think at some point I will add a start button here, but I kind of want to look for a different button. As far as the school project goes, I think I can just hit start on the laptop, and then at some point, yeah, I'll add the top button here, but I don't really have anything that would be used for at the moment. Okay, so this is the lane sensor so far, kind of what I've come up with. So it's on right now, so you can kind of see that when it pushed over, it comes out of the sensor, and as that light turns on. So you can imagine this is the lane, this piece would sit over the top, and so the ball is going to just come and whatever, right, push it back and forth. I'm still a work in progress. I'm not too sure how thick this piece is going to be. I'm going to try to get it to where it's
as thin as possible with the ball still being able to interact with it while it's riding the sides. Finally got the lane sensor working. Goodness gracious. Only like 70 tries. So you can kind of see there's the lever right here. So the ball goes over it. You can kind of see that light flashing in there, which you can see, right? So, and then it returns to the middle after it goes over it. So obviously I haven't, still don't even have the balls yet, waiting for those to even test that throwing it at it's going to work. But I think based off of testing the other ones, it should be okay. But there's like very little force required to push this over. Okay, so I got the flipper to work. So these are the solenoids that I got, and these things are huge. I think they have a lot more power than I really need. At 12 volts, they're pretty strong. The throw, after I've gotten this to work, is perfect. I do need the full 20 millimeters of throw, so that's nice. But here I can show this one working. I did mess up though. The ball does not fit behind it. I'm about to redo this section here to lower it. I could also just move the flipper more up, but I really don't want to do that. I kind of want to keep the same collinear nature of this. I did start to rough out the ball trough. Yeah, that's what it's called. I'll quickly show how this works. So obviously you can see the solenoid here is holding the balls. Pulls in, one goes out, and then it comes back in, and then one comes in here, and obviously it just shoots out. Okay, so here's a more better look at this. So I did use that M3 rod and bushings, which you can see here. So there's a bushing on both sides, and then which I glued in with some super glue. Problem is when I drilled the holes, I tried my best to make them straight, but they're not perfect. But it's okay. There's enough slop in the system that it's all right. So you can kind of see here, there's some set screws in the back. So both the flipper and and this piece have set screws holding them in, so they don't move. I ground the rod flat on where this is interfacing right here so that these can hold. I might make this larger though, so that there's more surface area for this to grab, because there still is a little bit of play. But yeah, otherwise the mechanism definitely does work really well. Let's see. I am a little concerned about, so this is at 12 volts, what they're rated for. This is not the MOSFET that I'm going to be using, but the other one is rated for like 3 times the amount of current as this. So I'm hoping that it doesn't heat up, because with this one at the 3 amp, 12 volts at 3 amps, this does start to heat up pretty bad, which on the manufacturing, or like on the web page or whatever, it does show that they need a heatsink for anything over 1 amp. So I think a heatsink would help, but I'm sure it's kind of hard to get one in there. And I think you'd probably need active cooling. So I got it to work. So I just have the flippers working right now. I did also put in the MOSFETs for these solenoids. So, but I haven't wired anything like that. I gotta basically write the program and everything for that, and then do some more wiring. But for now, I got the dang flippers to work. This took forever. But yeah, so basically those will push out the ball. Right now it's like too high, so it's not giving it enough power, but it definitely has enough power at 24 volts. Okay, so I figured out the best way to do the rollover sensors. It's actually inductive sensors. I had this Almiron switch or whatever from my 3D, one of my 3D printers, and figured that, why not just use something that detects a metal ball going over it? And these guys, this one specifically is not cheap at all, but there are, the round cheap ones are really cheap. I think on AliExpress they're about close to probably like $2 a piece, which isn't terrible. I ordered some off of Amazon, which were like almost double the price, but that's just for the fact that I have to get these within the next week to figure this out. But the issue that I ran into is obviously these run off of 24 volts, which means that the output power, like the output signal on these, is 24 volts as well.
Okay, so obviously a lot has changed since the last update. I think the last thing I talked about was the runover sensors. Hopefully they should be here soon, tomorrow I think, and I'll add those. But for now, I have all the programming done. The flippers work, the ball eject works, switches, the target switches up front work, and then I also added a ramp, as you can see. So I'll kind of break it up and talk about each of those individually. So let's start with the ball eject. So you can see here with the ball eject, there are two solenoids. So realistically, I had to begin with, just for there's enough so that there's enough spring force to stop the balls. Like when they come flying down, sometimes they hit pretty hard, and I don't want them to obviously go through. So I added two, but that actually worked out in my favor because when these retract, they're obviously electromagnets, so the ball actually does stick to it, to the like the centerpiece. And the way that I have these oriented, I'll show you in a second, basically pushes the ball out afterwards in a second. And then obviously this is kicks out. And then these are running on 5 volts because they don't need to be powerful. And then this one's running at the full 24 volts. I may change that depending. So you can see here, he ejects it. Show you again. Yeah, so there's obviously quite a bit of power there for that, so that's nice. So as far as the switches go, you can see that I have that RC circuit that I may have talked about earlier with a capacitor and a resistor, like a pull-up resistor, so they hold open longer. Realistically, I should have gone for a little bit longer of a delay because I still need 5 milliseconds to debounce the switches in the program. But honestly, 5 milliseconds is hardly anything, so that's pretty good. When you press all of them, it'll start the multi-ball, and then that ejects the ball. And there will be, for the lane sensors, there will be one here and here initially, just for the moment until I can get more, and then I want to build a PCB for those sensors so that it's easier to do. This one will detect when the balls come through. So in this case, for multi-ball, it would keep ejecting a ball as long as you're still in multi-ball, but it would only keep 2 balls in the playfield at all times. And then the obviously when you're playing without the multi-ball, it'll also take the ball, like you have 3 balls, and it'll slowly take away from those over time, and we'll detect this, and then I'll add a start button at some point to start the game. There'll also be a sensor right here, about right here, that will detect the ball when it has come over. So it won't have anything to do with the add a new ball to the table. So that's a whole different set than, or like a whole different function than the eject ball function. So, or well, it's part of it, but when the ball comes here after it's been added, if it comes in here, it detects that it's here and will continue to shoot it out until it gets out. The sensor will have nothing to do with when it's adding a brand new ball. That's all built into the routine. But if it does fail, right, if it does fail to shoot it out, again, it'll see that it's there and shoot it out just as if it was a normal, it went back in. Quickly going over the ramp though, talk about that real quick. The goes up, and then obviously just the 3 holes. It's fairly basic. There's a support here, basically one of these pegs used to be,
and then here, which just slides into that hole. It's kind of a tight fit, so it doesn't move. But yeah, it's in there. And then there's also 2 screws coming from the bottom to hold that in. The first print I had, this section was really messed up and wasn't really that flat, and it would actually jump out. And that's what this is for, so that it doesn't come up here and just act as a ramp and shoot out. So it definitely has enough power, the flippers, to get up and into there. And depending on how hard it goes, obviously, depends on which hole it comes out of. In order, like I said last time, in order to drive these, I need to essentially have the full 24 volts come for a couple, about 100 milliseconds, I think is where it is, 100 or 200 milliseconds. And then after that, it needs to be at a significantly lower voltage or lower PWM, so that the the solenoids themselves do not burn out. Basis of this is PWM controlled MOSFETs right here. These guys are awesome. So you can either just do full on open and close, just like a normal, but these guys have like a significantly higher power limit. Like, they've never gotten hot on me. And then they're also PWM controlled, which is nice. In order to get the PWM signal, I'm using a microcontroller. So when I first started out, I couldn't necessarily get the program for the microcontroller to work very well. I attempted to move to a switch design so that when the flipper fully retracted, it would hit a switch and transfer to a different MOSFET that had a lower power going through it, whether or not that was like just running off the 5 volts or running on a PWM signal. And that's what I attempted to do at first, and it didn't work very well. My circuit was working, like it would hit this and it would switch, but for some reason the voltage was backfeeding and I was getting 24 volts the entire time. It could have just been the fact that I don't know, I couldn't verify that the PWM on the microcontroller was working. Like, per flipper, I think it was like 3 of these MOSFETs, which was just ridiculous. Like, the wiring was super complicated, plus you had all the switch and everything. So finally I just sat down to try to nail out that programming on this. And so I was trying to use like interrupts, hardware timers, trying to get it like to where it's as fast as possible. Realistically, the solution ended up being just the fact that the only thing this microcontroller does is read whether or not the button is being pressed, right? All it does is go through, reads the state. If it's high, it shoots it off and starts the 200 millisecond timer, which is just a millis function. And after that, drops down, so you can hear the solenoids are buzzing, and they're running at 1.5 volts is what they drop down to hold them there. The solenoids that I have, that I'll show you in a second on the bottom, are like really big. Actually, they're almost the same size, if not maybe a little longer than the actual pinball, the ones on an actual pinball machine. So I think I did pretty good there. But I'm also running them not at the full 24 volts. I think I have them at 65% power for just normal play, like for the initial push. So they're definitely are way too strong. I think something like this, just with that 25 millimeter throw, would have been perfectly fine at the full 24 volts, obviously. But you can also see here in the back the wiring. So this is the main ESP32 controller. It'll have all the sensors and all the switches and stuff. And then so one core is running the switches and sensors, and then one core is doing all the logic for the rest of the game. So when you press the start button, it does the start sequence, ejects the ball, etc., etc., right? Controls all that stuff. You can see these 2 signal wires to the MOSFETs for the ball kick and the ball trough ejection. Here's the 5 volt, the 24 volt to 5 volt thing, and that's applying the 5 volts for the entire system. And that I am using these nice Wago connectors for like everything. So one side is 5 volts and then one side is 24 volts, and that's kind of what I've been doing. Makes it really easy. You can see here, ball's on my other hand. When the ball goes in front, the LED turns on. So that's good. Okay, so I got the sensors working. The 2 sensors, so you can see the ball trough sensor right here. So that's going to detect when the ball, like you basically lose the ball and it comes through. And then here's this one, which detects specifically if the ball has entered from this direction, not the other way around. So it doesn't care about whether or not it's coming from here. If a ball comes in there when it's not supposed to be, it ejects it. That's basically all that sensor's there for. But I'll show you the starting sequence here. I'll add a start button at some point, but just powering it on starts it. So it's going to eject a ball, shoot it, obviously, right? So then it comes across, and we'll keep going until it basically runs out of, like you do all. So this is your last ball, because that was 3 balls, right? So for whatever reason, the ball comes back in, basically shoots it out. And the nice thing is it's strong enough for 2 balls. So for whatever reason, if 2 balls were to go back in, it'll shoot them out. Okay, so I've also got the scoring screen working. It's pretty basic. There's a start screen, which is what you're looking at, the scoring screen, the end screen, and then there is the target multi-ball screen for both the starting and the ending. They're technically the same function. It just changes whether it says starting or ending depending on where it's at. So I can show you this. So you press the start button. So go ahead and went into the scoring screen, and then when you obviously start scoring, start showing up. And so this is wirelessly connected over ESP now. Eventually I'll get the serial, but I'm having problems with figuring out the serial on there. But as you just saw, there's the multi-ball just started, so it flashed, so now it's going through. The multiplier is down there, and then the ball count is down there. So as soon as this minute multi-ball is over, I'll show you. Alright, so you can see here the multi-ball is flashing over, and then goes back to the score screen. And so at the moment, it knows that there's 2 balls on the table because there's a multi-ball. So I'm going to drop 1 ball in, and it's actually going to register that 1 ball was minus from the table. So you can see that the balls weren't gone down. As soon as I let the other one go down, though, it's going to add another ball and take one away. So I also added the button on the front here. In order to, at the very beginning, when you get a new ball, you do have to press the button to shoot it off. So that's really nice now. But then there is also the mercy period of like 15 seconds. So if whatever reason you don't get it within that certain period of time, it'll shoot the ball out for you again. And then yeah, so now this game's over. So it gives you the score, your score, whatever. It holds it there for a little bit, and then changes back to the start screen. And it'll at the moment it just shows the last score. Eventually I'll have it to save the high scores in the memory, and then it'll slowly cycle through high score number 1, high score number 2, high score number 3, and then if there's like any other high score stuff, it'll also be displayed there. Eventually I'll get into animations and do all that kind of cool stuff. But yeah, for now though, everything works. You can play the game and everything. Okay, so I'll go ahead and walk through each of the systems first, show them, explain what they do, and then I'll actually just play the game and show you how it works, and to show you all the features working while it's on. There is one ESP32 controlling the flippers. This is only for the flippers, so it controls these 2 PWM controlled MOSFETs right here, and that's for the flippers, so that when you press the button, it gives 100% PWM. After 200 milliseconds, I believe is what I have it set to, it'll go into partial PWM, so that the solenoids don't burn out. I have the kicker solenoid to shoot the ball out. There's these 2 solenoids that keep the balls in the table. This MOSFET's for this solenoid, and this MOSFET is for these. There are targets with micro switches underneath of them, so each of them scores. So this is the only scoring thing I have at the moment until I get more all the lane sensors, and then the other stuff going on inside your slingshots and whatnot in the loop. Otherwise, also have the scoring screen, which shows your score. There is a button here to start the game and shoot the ball as well. I have the 24 volt power supply right here. There's a 24 volt to 5 volt converter right here to run the 5 volts for the rest of the system, and 5 volts for the 2 ball lock solenoids. The main controller, which is this ESP32 right here, and this reads all the sensors and runs the logic for the game, and also communicates via ESP32 now to the ESP32 screen that I have set up here. You can see the 2 flipper solenoids right here, and right here I had the 2 inductive sensors to detect the metal ball.
So in order to start the game, you just press the start button. So it's going to grab a ball, shoot it into here. In order to start, you got to press the button again to shoot the ball. Shoots the ball out for you. And then you can start playing. You can see that when I'm hitting that target up there, it is scoring whenever I hit the targets. The ball comes in here, it'll notice it and cut it out. So in this case, so I just lost the ball. The ball count over here dropped to 2. You have 3 in total, and so that tells you which ball number you're on. And then again, you have to press the button in order to shoot the ball out. So I'll also go ahead and show the you've actually seen the switches score, so you can see the score is going up. And then if you press the switches all like at the same time, they will register. So I pressed all 3 switches and all 3 switches went off. If you press all 3 switches or all 6 switches on the playfield during the same ball, it'll start a multi-ball. So I'll press these other 3 and then I'll show you that. Oh crap. Okay. So it now just ejected another ball, told you that the multi-ball started up there, the screen flashed. So now it knows that there's 2 balls on the table and will keep 2 balls on the table for the next minute. So I can drop these and it'll actually shoot out 2 balls. And then we'll continue to do so for the next minute. As long as it just keeps 2 balls on the table consistently. So now you can see that multi-ball is over, so it's going to flash that it's over to tell you that it's over. And then it goes back to the normal screen, so it still knows that at the moment there's 2 balls on the table. So if I drop a ball, it's going to subtract that ball from the count that it has of how many balls are on the table, but won't add any more. And the ball count over here has still not changed. So until I lose this ball right here, it'll add another. It'll subtract 1 over here, and then you can get another ball ready for you to play. And then there is a mercy period. It's where if the ball goes in at a certain time after it's first shot out, it'll automatically shoot it out for you. A ball save is what they call it. But so then I lost that ball. It'll display the final score on the end screen for a moment. I think it's like 15 seconds. And then we'll go back to that start screen. And then same thing again, you can press the button to go over again to play the game. And it just all starts over again. And you can press the start button during the end screen and everything will work still. You don't have to wait for the start screen to go up. And then obviously the button doesn't, while you're playing, the button doesn't do anything. Okay, so I'll just go ahead and sit here and play the game for a minute or 2 and just kind of, so you can watch it.
That's that mercy period I'm talking about right there. So yeah, mercy period is over right there. I have to subtract the ball. Eventually there'll be covers over there, so that doesn't happen. Nope. Ah, game over. Go again. The how much force it needs when it comes out probably needs to be changed. But I have it high just in case. I have it high just in case two balls come up. If you made it this far into the video, thank you. You're a real Chad. I did present my pinball machine and received 100%, so yay. The 2 grueling weeks were definitely worth it. I learned a lot from this project, so despite its difficulty, I'm really glad that I actually took it on. Something myself and other students learned in doing the final project is understanding your limitations. Just because it's simple doesn't mean it is, especially if you have no experience doing something. Just because someone made a tutorial on YouTube does not mean that you're going to be able to do it easily. However, if you feel like quitting because something is too hard, just keep trying. You'll get there eventually. I was only able to finish this project because I didn't give up. If I had, you wouldn't be seeing this video, or at least the pinball machine wouldn't be working as well as it does now. On a positive note, get subscribed because I'm going to continue to add to the pinball machine and make it way better than this.